Alright, so we got our data PID list here pulled up on ShopStream Connect. We're going to go over all the different PIDs and what they should be doing. So we're going to start on the top left here, engine speed. That's just engine RPM, engine speed. Battery voltage is a good place to check your charging system. I always like to check it with a meter at the battery itself and do your voltage drop checks there also. But as you see here, minimum is 13.8 and maximum is 14.3. So this movie must have started with the engine running. But it looks like the charging systems are working very well. Accelerator pedal position, just that. It reads how much you are on the gas. And that's in percentage on this one. Front wheel speed is in mile per hour. This is also a good vehicle speed sensor. The vehicle's speed is the same as the wheel speed sensor. Transmission fluid temp, they have it reading in Fahrenheit. It started out at 84 degrees and went to 104, so we're not warmed up yet, but it is reading in degrees. It doesn't give us a voltage reading. I prefer voltage myself, but degrees works good for when you need to get your trans temp to the correct temperature to be able to check the fluid level. So you can check that on the scan tool there. Your lockup duty ratio percentage, as we have learned, I'll click here where it starts ramping up. We're at 38% duty cycle on the lockup solenoid. Let's go over here to vehicle speed. We're at 4 miles per hour. So lockup duty cycle is starting at 4 miles per hour to apply the lockup clutch. We'll click here at full lockup, 99%, pretty dang close to full. We're at 11 miles per hour. So start ramping up around 11 miles per hour, it can be fully locked. Your transfer case duty percentage, this is your transfer case clutch basically. When you accelerate hard or accelerate, see from here we're at a 26%. Right before it we're at 0. So we accelerated right here. The accelerator position showing the change in the accelerator, and it's also putting more oil to your transfer case clutches to apply them to be like an all-wheel drive or four-wheel drive mode, so we're not peeling out. Normal duty cycle, let's see, transfer case duty ratio, we're at 30% right here. We're at 3 miles per hour. Let's find a spot where we're going 0 miles per hour, so we're sitting still. There we go. 0 miles per hour. We're still roughly at 30%. Let's go over here. We're at 1 miles per hour. We're at 35%. So roughly in that range of 30% transfer case duty cycle ratio is normal at a standstill, and with engine loaded it's going to increase. So we're over here to actual secondary pressure, PSI. This one's a little confusing because it says 0.147. This is actually 147 PSI. Click over here, 0.369. That's actually 369 PSI. So the way they have it written is kind of strange on the data list, but just remember to remove the decimal point. Secondary solenoid set current. Set current is what the computer is wanting. And the next PID over here is secondary solenoid actual current. That's what's actually on the solenoid circuit itself. As you see, these are matching, and this is correct. This is what you want. You see 520 here, 530 on this side. So those numbers need to be close to each other. It's kind of similar to a 48RE governor circuit, actual and desired. Same kind of concept here. Same concept actually is for your forward and reverse linear solenoid. Commanded is what the computer wants. Actual is what is on the circuit. So you see here it's 669 on the actual, and commanded is 677. So they're fairly close. Usually within 10ish is what you want. The lower amperage here, the more pressure to the forward or reverse clutch. You see where this cursor is now, it's dropping in amperage, and you see this is where we're accelerating, so it's actually putting more forward clutch oil to that circuit to keep that forward clutch from slipping. So as we're accelerating, quite a few things are happening. Of course, the accelerator pedal position is going up, your transfer clutch duty percentage is going up, and your forward and reverse linear solenoid drops amperage, and at the same time your secondary solenoid is dropping amperage to raise mainline pressure too. Primary speed, pulley speed RPMs is measuring off the primary pulley itself. Secondary pulley speed RPMs is measuring off the secondary pulley. They use those numbers for calculating the ratio and also to see if the chain is slipping to set it in limp mode if it is slipping for some odd reason. The primary up duty percent is adding oil to the primary circuit to change the ratio closer to the overdrive position. When the primary up duty cycle has current, you will see no current on the primary down duty cycle. Went over this on another video, so I'm not going to go into it again too much. Primary down is draining oil from the primary pulley circuit, and the ratio is going closer to first gear. Alrighty, and let's see, secondary pulley speed, primary pulley speed. So what happened here? Oh, okay. Yep. So we had one extra, and we're adding the actual gear ratio. So this is the new pit on the screen. Sorry about that. So the actual gear ratio, this is actually the gear ratio that is happening. As you see here, it says 2.27, and we're basically at 2 miles per hour. And as we accelerate, we're accelerating here, and the percentage ratio is dropping down. And at this time, your primary up is putting more oil in there in the primary pulley to change the ratio. When the ratio starts going the other direction, you see that the primary down is draining oil from that pulley, and it changes the ratio. So those are the main PIDs in transmission data 1. These are all good PIDs off a good working vehicle, and we'll move on to the next set of PIDs.